Hello everyone. In this lecture, we are going to discuss about the uncertainties in construction management. That means the uncertainty in duration of the project or the individual activities inside a project. So these uncertainties may be because of several factors. We will discuss them. For example, some uncertainty and most of the uncertainties are because of weather conditions, because construction activities are mostly outdoors and all those outdoor activities are very much dependent on the weather, and therefore since weather itself is a random phenomenon, and therefore it will lead to some kind of uncertainty in the activity duration and therefore the total project duration. Similarly, natural disasters like flood, earthquake, forest fire and so on, so they will also lead to some uncertainty. Then material and labor or manpower availability in some places will also lead to uncertainties, and social and political disturbances in some times and in some places will also lead to uncertainties. In addition, extreme events or very unlikely events such as what is happening right now due to the COVID situation, so these are also causes of uncertainties. So how do we deal with it and why do we have to deal with it? So let's try to understand how we deal with this uncertainty, because if you make an estimate that a certain project is going to be completed in suppose 50 days, but in some cases if all the things are in our favor it may take even 40 days, but if everything goes wrong then it may also take 70 days or 60 days. So in that case we'll have to deal with it in a different way, and that is by using the concept of probability. So therefore the duration of a project can be expressed as a probability distribution rather than a fixed estimate of time. So that means in the previous lectures where we discussed the critical path method, we would say that the total duration of the project is approximately, we'll not use the word approximately there because we'll simply deterministically say that the project will take suppose 50 days, but that is the estimate based on average. But actually in it may take suppose 30 days, but if everything goes wrong it may also take 70 days. And that is why instead of a fixed estimate like this or this or this, we use this kind of a probability distribution, and from that we can say that this is the probability of completing this project within 30 days or 40 days or 50 days and so on. So just a brief idea of this distribution: if it is symmetrical, that means if it is a normal distribution, then we can say that if whatever time this represents, so in this example it is 50 days, that means if it is a normal distribution then there is 50% probability or 0.5 probability that the project will be completed in 50 days. However, since this distribution goes only up to this much, that is 70 days, that means the maximum this project will take is 70 days. So you can say that there is 100% probability that this project will be completed in 70 days. That means in no circumstances it will exceed 70 days. However, in theory, this tail will not meet the axis here. It will go a long way up to infinity. That means we can never be 100% sure, but it is suppose close to 99.9%. Now this distribution is generally assumed to be a normal distribution for the entire project duration. However, it is not always the case that this distribution will be a normal distribution. Now, the advantage of expressing the total duration in terms of probability is that what we have already discussed. That means you can tell the client that there is a certain amount of probability, that there is suppose 20% probability, if we look at this picture here, that, and if this area, this shaded area, if it is 20% of this total area of this diagram, then we can say that there is 20% probability that the project will be completed within, suppose if this was 50 days, this is 41 days. So within 41 days it can be completed, but there is only 20% probability. However, the 50% probability is for suppose 50 days, and if we go to this point, then it will cover a larger area like this, and that will become about 70% of the total area of this whole diagram. It is area under this curve, and that would mean that there is 70% probability that this project will be completed within these many days. Suppose this is about 62 days. So we can say that there is 70% probability that the project will be completed within 62 days, and so on. So this is the main advantage or main utility of expressing this project duration in terms of a probability distribution rather than a fixed estimate of days or weeks. So when we do this, we do not call it the critical path method, but we call it PERT, or program evaluation and review technique. So in this technique, probabilistic estimate of the project duration is obtained. We'll discuss this whole method in a separate lecture, but this lecture is only to give a brief introduction about the nature of uncertainties. Just like this total duration, all the individual activities are also probabilistic in nature, because suppose if you consider a certain activity, suppose earthwork, excavation or filling or both, then it may take, if this is a timeline, it may take suppose 10 days, but it may also take at the maximum suppose 30 days, but most likely it is going to take 20 days. When everything goes in our favor, suppose all the conditions are very good, in that case it will be completed within 10 days, and otherwise if everything goes wrong, then it will be taking 30 days. So different activities will have different such probability distribution instead of a fixed time estimate. So if you remember the bar chart or the Gantt chart for different activities, then we used to make this kind of graphs for different activities. But in this case, if we are to take into account the probability or the uncertainty of the total duration of an activity, then this line, the end, will not be a fixed line, but it will be blurred, and it will be represented by this kind of a probability distribution. Each of these durations will be a probability distribution of its own. Now there may be various types of probability distribution. For example, you are very familiar with the normal distribution. So a normal distribution is symmetrical about its mean or about its midpoint. And one interesting thing is that, or peculiar thing is that, the mean, the median and mode, they're all the same in case of a normal distribution. However, it is not the case for some other distributions. So those other distributions may be something like this or this. So in these two distributions, as you can see, they are not symmetrical, but they are skewed to one of the sides. In this case, it is skewed to the left, and in this case, it is skewed to the right. So what do they mean? It means that although this activity, suppose any activity A, it can be completed suppose within 7 days if everything goes right, but it may also take about 17 days if things go horribly wrong. However, in most of the cases, it will be completed within suppose 10 days. So generally it is close to the optimistic estimate, and but sometimes it may happen that it will take longer than 10 days, and at the maximum it will take 17 days. In the other type, that is the second type, here we can see that it is skewed to the other side or the longer duration. That means if it is taking suppose 7, let's take the same example, 7 and 17. So in this case, most likely it is going to be completed within suppose 14 days, but if everything goes wrong, then it will take 17 days, and if everything goes right, then it will only take 7 days. But in both these situations, the difference is that in this activity or in this situation, it is more likely that it will be taking a shorter time, and in this case it is more likely that it will be taking a longer time, which is not the case in case of a normal distribution. It is not skewed to the left or right, it is perfectly symmetrical, and that's why it is called a normal distribution. That means when all the things are normal. Some other details about these distributions are such that if we have a distribution like this and we have another distribution like this, now the difference in meaning of these two distributions is that this distribution, the narrower one, shows a less degree of uncertainty. That means your estimate may vary between suppose 12 days and 15 days. That means there is only a difference of 3 days between the best possible condition and worst possible condition. And generally these kind of activities are indoor activities where the outside elements do not affect our workflow. However, in case of outdoor activities and activities to be performed in new places, then the probability distribution is wider because we do not know the situation, we do not have lots of control over the situations and working conditions. So it may be very good or it may be very bad. So the probability distribution is very wide, and it may be completed suppose within 5 days, but it may even take 30 days and so on. If you want to have just another relatable example, you can take the example of marks secured by the number of students in an exam. So in a normal exam, suppose the highest mark somebody gets is 99 out of 100, and the lowest somebody gets is about 25. However, in case of a paper which is very difficult, then most of the students will be getting less marks, suppose close to 25, and very few students will be getting marks close to 99. But if the paper is very easy, in that case, most people will score higher, suppose 70 or 80, and very few people will be getting less marks, and still a very small number of people will get close to 90 or 99. So that's the meaning of this kind of different distributions. Now, one problem with this kind of distributions, the skewed ones, is that they are difficult to deal with mathematically, but we are very familiar with normal distribution and how to operate with it. So in this topic, we will try to convert everything into a normal distribution, because if it's a normal distribution, then we can find out the standard deviation, the z value, and therefore we can find out the different probabilities. Suppose if somebody asks you, can you complete the project in 20 days, then you look at the distribution, you see that it starts from suppose 18 days and ends at 32 days, and in the distribution you look at where is 20, which is suppose around here. Now you simply find out how much is this area, and for finding out this area we have the normal distribution table, which can be found anywhere. It's probably there in the back side of your statistics book, and it can be simply downloaded from the internet, and it's easier to deal with. And therefore, instead of using this kind of distribution or this kind of distribution, we'll try to use a normal distribution like this to make our calculations. But the problem is the actual distribution is simply this one. So how can we ignore this nature, the skewed nature, where it is not normally distributed, and use a normal distribution? For that, there is something called a central limit theorem. Central limit theorem, using which we'll use it as a trick, and we'll try to convert all our problems into normal distributions, and then we'll deal with the mathematics. So for central limit theorem, I'll try to prepare a separate lecture rather than putting everything in this single lecture. So this is how we'll deal with the probability and the uncertainty in duration of different activities involved in a construction project. In this lecture, I'm not dealing with the mathematics. So in the subsequent 2 or 3 lectures, we'll be dealing with the actual techniques of how to do and how to operate these kind of principles to actually find out the activity duration and their probabilistic estimates. Thank you.